So today's lesson is going to be really overwhelmingly difficult.
It is.
So basically our objectives for today are very simple. Classify triangles as to basically acute, obtuse, or scalene. Isosceles equal lateral equal angular. And then we're going to utilize the interior sum theorem, exterior sum theorem. And then eventually today you guys will have to prove the exterior angle theorem. So, let's start off really basic here. When looking at classifying triangles, you can classify them in two ways. You can classify them based on the lengths of the sides or the dimensions of their angles. So what I want to do first is I want to talk about classifying based on the length of their sides. And I know it's going to go a little bit grade school, but this is terminology you guys need to know in order to be proficient in this class. So one of the first ones, Sean, we're going to be looking at something called a scalene triangle. What is special about a scalene triangle? Sarah?
All three lengths or the sides, they have different measures, they don't have the same.
Yeah, so we don't have any common side lengths. Alright, so that's what you need to know about scalene triangles. We have no common sides. So all three sides are different. So Matt, what is special about an isosceles? And what else?
Has three sides.
And keep going.
Has 3 points.
Keep going.
Is equal to 180 degrees.
Keep going. This right here is an isosceles triangle. What's special about that isosceles triangle? Chris?
To the side of the center.
Yeah, we had two congruent sides. Hey, Matt, we're going to come back to you, so I'm not letting you get out of this. On the bottom one.
Has 3 equal sides.
3 equal sides. Imagine that. Equal meaning equal, lateral meaning side. So we have 3 congruent sides. What I'd like you to actually do right now is I want you to put the tick marks on your diagrams. Just to show that those 2 sides are equal and those 3 sides are equal as well. Alright, so again, this is just some really basic terminology that we're going over. Next what I want to do is I want us to look at this in terms of the angles. What makes a triangle an acute triangle? What does it mean to be an acute angle? Sam?
Less than 90 degrees.
Okay, so less than 90 in order to be an acute angle. So what makes it an acute triangle?
Angles are less than 90.
All of its angles are less than 90. Okay, so for an acute triangle, all 3 angles must be less than 90 degrees. All 3 angles are less than 90 degrees. That's an example of an acute triangle. Very small. Very, very simple there. Less than 90. So what makes something an obtuse triangle? If an acute triangle is one where all 3 angles are less than 90, what makes something an obtuse triangle? Sam?
Their angles are more than 90.
Sam, I want you to think that statement through a little more. Taylor? angle is above 90. So the triangle that has one angle greater 90 degrees. Okay, this is where we need to actually stop and have a discussion. Earlier, you guys proved that the sum of the interior angles of a triangle is what? 180. Can a triangle have more than one obtuse angle? Okay, look at you're shaking your head no. Why not?
Because if you had two sides that were more than 90, that'd be more than 180, and you wouldn't be able to have first.
There you go. If we had two angles that were more than 90, then it's automatically going to have more than 180 degrees, which violates the interior sum theorem. So that means a triangle can have exactly one obtuse angle. That's all they can afford. They can have one, not more than one. They can only afford to have one. Okay, Kirsten. What makes something a right triangle? It has a 90-degree angle. Let's draw our diagram here for obtuse angle. And so we have one right angle. Can a triangle have more than one right angle? Why not?
Because the two right angles was 180 and it wasn't square.
There we go. Now, if we leave planar geometry, that statement is no longer true. Okay, equiangular, what does that mean? Chris?
All three 360 degrees.
Yes and no. Yeah, a little more specific than I was ready for. What it basically means is that all three angles are equal. But since the interior sum is 180, that means that all three must be 60 degrees. So it's basically, by definition, equiangular means that all three angles are equal. Not necessarily that they are 60. It didn't show that they're 60. So all three angles are equal. Is an equiangular and an equilateral the same triangle? Is equilateral and equiangular the same triangle?
No, because one has like the side length are the same and the angles are the same on different ones.
Well, would being one force you to be the other?
Yeah.
Would being equilateral force my triangle to be equiangular?
Yeah, because if you were to have like one side that like isn't the same, then it'd be yeah.
Yep, they are the same. So equiangular and equilateral are the same thing. We just look at them differently. Equiangular is looking at the triangle strictly in terms of its angles. Equilateral looks at it in terms of its sides. Okay? Kids, are you getting all this down?
Yes.
Okay, so, yes.